Good morning everyone and welcome to today's webinar, our 9th of 2022. If you've missed any of our series, which has been running for over 2 years now, you can view them all on demand right here on our YouTube channel or on our Learning Hub at www.proctorgroup.com. You can also now register for our online members area where you can access product information libraries, personalised CPD certification and our free online U-value and condensation risk calculator. As always, you can also request product samples, arrange follow-up meetings to discuss the specifics of your project, or book one of our expanding range of REBA assessed CPDs covering a range of topics. This can all be done either face-to-face with our team of experts across the UK or online. Today we're going to look at the Technical Guidance Document GD40, released by the Metal Cladding and Roofing Manufacturers Association in February 2022. Titled Understanding Membranes in Ventilated Rainscreen Facades, this document details the fundamentals of membrane performance in facade systems and how this relates to the guidance given in BS 5250-2021, the Code for Practice for the Management of Moisture in Buildings. After the presentation, we'll be joined by MCRMA Director Carlton Jones, who will be answering your questions alongside our team of technical experts. GD40 aims to present an overview of the key design elements affecting the specification of ventilated facades and how construction membranes interact with them. Today's presentation will follow the structure of the document itself in reviewing these elements. We'll begin with the terminology used in discussing membranes and then look at membrane placement and how this can affect controlling moisture vapour transfer and air leakage. We'll then consider how the BS 5250 Code of Practice and condensation risk calculations can be used to assess performance and demonstrate compliance. We'll then move on to fire performance and approve document B, before finishing up with a look at installation and detailing and the way we, as manufacturers, can simplify the adoption of best practice. The building regulations across the UK and Ireland reference the guidance given in the BS 5250 Code of Practice. First issued in 1975 and most recently updated in 2021, this document now deals with the management of all forms of moisture in the building envelope, not just condensation. It serves to identify and explain important design criteria and specifies a detailed and consistent approach to hydrothermal design and associated data. Alongside this first principles guidance, it also specifies a range of constructions and details across all types of common constructions and build-ups. We've covered BS 5250 in a lot of detail in previous webinars, not least in a special guest webinar from Chris Sanders, former chair of the BSI committee and responsible for its development. So for anyone wanting a deeper dive into the details and specifics of this, you can find them both on our YouTube channel and on our website Learning Hub. The first reference point that the GD40 document makes to BS 5250 is in terms of the terminology used. BS 5250 defines specific criteria for most parts of the building envelope that affect its hydrothermal performance, but GD40 focuses mainly on two of these component definitions: air and vapour control layers or Avcls and vapour permeable membranes. An air and vapour control layer is defined in BS 5250-2021 clause 3.1.3 as a continuous layer to restrict the movement of air and water vapour. This is a fairly self-explanatory definition, and membranes of this type are added to constructions to control the passage of air and water vapour into and through the fabric of a building element. In rainscreen facades, a low permeability membrane is the most common and usually simplest form of Avcl, but impermeable components such as a foil-faced insulation or steel profile sheeting can also function as Avcls if specified and installed appropriately. In the UK, the climate dictates that vapour typically moves outwards from the warmer interior to the colder environment outside, so this type of membrane is placed on the warm side of the insulation. In this position, it prevents the vapour moving to colder areas where it can condense into liquid water. The A in Avcl refers to the ability to inhibit the movement of air, but whilst all vapour control layers will restrict air movement, not all airtight layers restrict vapour movement. Sometimes it's advantageous to use a membrane which is airtight yet vapour permeable, and we'll discuss this, along with envelope airtightness shortly. It used to be common to refer to Avcls as vapour barriers. However, this terminology implies they are 100% effective at preventing moisture flow, which is rarely the case. Fixings, jointings, and detailing, as well as service and structural penetrations, will all affect their effectiveness, even in high-quality installations. In practice, all layers of a construction affect the passage of moisture to some extent, so considering this holistically and using these properties to manage the moisture flow is a far more robust approach than assuming a single barrier will resolve any moisture issues. We'll discuss in more detail how BS 5250 recommends these assessments are conducted later in the webinar, but let's consider the other types of membrane GD40 references. Breather membranes, or more accurately, vapor permeable membranes, are defined in BS 5250 Clause 3.126 as being membranes with a water vapor resistance SD less than 0.12 meters or 0.6 meganewton seconds per gram, but greater than 0.05 meters or 0.25 meganewton seconds per gram, used in walls, sheeted metal roofs, and flat roof constructions. The lower limit and the latter part of the definition are important. Vapor permeable membranes of below 0.05 meters are technically classed as being type LR roof underlays, and therefore are typically used in slated or tiled roofs rather than walls. This does not mean that a walling underlay that is 0.05 meters or lower cannot be used, as it's still applicable as a vapor permeable membrane. Pitched roof applications require a higher level of vapor permeability to function effectively compared to walls, which BS 5250 recognizes by separating vapor permeable membranes into two classes: vapor permeable membranes and LR low resistance underlays. Vapor permeable membranes have two functions. Firstly, to provide temporary weather protection during the construction process, and then once the envelope is completed, to permit the escape of water vapor from the building. In the event of damage to the outer weatherproofing layers, such membranes can also provide limited temporary protection until repairs can be undertaken. As with vapor barriers, older but still common terminology like breather membrane doesn't always fully clarify these performance distinctions. While the BS 5250 text makes it clear breather membrane should only refer to membranes used on walls, in practice this isn't always the case, particularly among merchants and contractors. Well-written and comprehensive performance specifications, along with the correct standards-defined terminology, are highly recommended to avoid confusion. A modern building element can be very highly engineered and relies on precise material specifications being adhered to in order to ensure design calculations and assessments remain valid and compliant. Some vapor permeable membranes are airtight, contributing to the building energy performance, whilst others may be UV resistant to allow their use behind open-jointed cladding. On top of this, they may or may not be appropriately fire rated for the specific application. Simplifying this into a simple term like breather membrane is no longer sufficient to prevent incorrect products being installed, and hence ensure as-built performance meets the design criteria. To illustrate the placement of membranes within a facade wall, GD40 takes two examples from BS 5250. The base wall is of SFS construction, with sheathing over the steel frame and insulation placed both between the frame and continuously over the sheathing. The document then considers both open and closed jointed facade cladding to the outside, with a ventilated void behind. In this wall construction, there are three possible membrane locations. On the warm side of the insulation being the internal lining, over the sheathing between the two layers of insulation, and outside the insulation layers in the ventilated cavity. The specification of membrane required varies across these three locations, and whether or not a membrane is required in each location is also dependent on a variety of factors. The traditional approach would be to have an Avcl internally to prevent both moisture ingress and air leakage, and a vapor permeable membrane externally to protect the construction until the outer cladding is fitted. There's nothing wrong with this approach on paper, but there's scope to optimize performance by considering alternatives. If we carefully consider our moisture movement, an internal vapor barrier may not be necessary, and indeed is considered optional in BS 5250. For example, if the vapor resistance of the insulation and sheathing layers are sufficient to limit condensation risk themselves, and this is confirmed by a calculation, then the VCL can be safely omitted. This would allow us to move the airtight layer to the middle of the insulation layers, where it's less likely to be damaged by following trades. In this position, the membrane would need to be airtight but vapor permeable in order not to trap moisture. Similarly, the outer vapor permeable membrane may not be needed if the insulation can be left exposed during construction or will be covered over quickly enough not to pose a problem. This would mean only a single membrane is required in this construction. If we have open-jointed cladding, then the outer membrane would again be needed to protect from water ingress during construction and through the open joints or perforations. This membrane would also need to be of suitable UV resistance to resist the long-term exposure inherent in using open joints. BS 5250 looks for membranes used in this application to achieve a Class W1 weather tightness rating after 5,000 hours of UV aging in accordance with BS EN 13859 Part 2. It also requires an SD value of not more than 0.25 metres, with condensation risk calculations required if it's above the typical cutoff point of 0.12 metres. So, we can see how the characteristics of construction membranes affect how we use them, and how this affects the wider build-up. Let's now consider in more detail how membranes are specified and assessed in relation to air leakage, moisture control, and fire performance. Good air tightness, or reducing planned air movement through the building envelope, is an important component of the overall energy performance of structures. As the levels of fabric insulation in buildings increase and HVAC and heat recovery systems become more efficient, minimizing air leakage is critical to ensure everything else works optimally. All the energy assessment methods in common use, such as SAP, SBEM, and the Passive House Planning Package, all holistically consider the effects of air tightness and insulation on overall heat loss. This means low air leakage can be traded off against other aspects of the energy performance, where appropriate. The flip side to this is that a failure to achieve the specified air leakage rate in pre-completion testing can lead to expensive and complex remediation to comply with building regulations. So, it's important to get it right, both at the design stage and during construction. As we discussed earlier, the conventional approach to this is to use the vapor control layer as an air barrier and seal everything up on the internal side of the wall. If this approach is taken, the correct detailing, jointing, and sealing of the VCL become very important, and any gaps or damage will affect the air leakage. Penetrations for building services such as power and plumbing must also be fully sealed. Achieving the degree of sealing needed to achieve a low air leakage rate requires multiple specialist tapes and sealants, airtight sockets and switches, and above all, experienced and highly skilled contractors. Following trades during construction and in the future also need to be aware of the importance of this airtight layer and have the skills, experience, and materials to undertake their task without compromising it. Service voids internally can help mitigate the risk of damage to the AVCL, and this approach is strongly recommended if an internal VCL is used as the airtight layer. It still needs a bit of careful system design to ensure service runs are optimized and penetrations through the AVCL are minimized, however. The alternative, moving the air barrier outwards in the construction, goes some way to resolving this, as there are far less service and structural penetrations in the outer parts of the wall. This is a similar principle to wrapping presents, then putting multiply awkwardly shaped gifts into a square box makes wrapping the whole lot easier, faster, and a lot neater. In this location where the membrane is in the middle or on the outside of the insulation layers, the membrane should be vapor permeable to prevent moisture becoming trapped within the construction. We'll discuss how that works in a little more detail shortly. Most membranes used in this application are mechanically fixed and taped into position on the sheathing board, so there's still a degree of jointing and sealing to be done with these products. Products like our Wrap-Tite, which is fully self-adhesive, can simplify this sealing, making achieving a good quality installation faster and simpler than if tape joints are required. Self-adhered membranes are also fully bonded to a rigid substrate, eliminating the potential for wind to damage the membrane by straining staple fixings or tape joints. This is particularly important on taller buildings or in more exposed locations. Damage to mechanical fixings can open up gaps in the membrane, not only increasing air leakage but also increasing the possibility of water ingress. Taken together, these properties make a self-adhered vapor-permeable air barrier a much more robust and durable solution to achieve very low levels of air leakage. This allows lower values to be used at the design stage in order to maximize the performance benefits with less potential for complex and expensive remediation due to missed targets in pre-completion testing. We discussed earlier how an intermediate or external airtight line may remove the need for a vapor control layer internally. This generally requires confirmation of its suitability by means of a condensation risk assessment calculation, and we'll look at this in more detail now. The GD40 document refers to the two methods given in BS 5250-2021. BS 5250 was, until the 2021 edition, the code of practice for the control of condensation and was heavily focused on condensation risks. The 2021 edition, however, has broadened its scope to encompass the risks associated with building moisture in general, regardless of its source, and this holistic approach to hygrothermal design is something we've long advocated here at the Proctor Group. BS 5250 specifies two methods for assessing condensation risk and discusses the pros and cons of each. The first method specified is the Glazer Method, as defined in BS EN 13788, which uses a simplified steady-state analysis to assess the temperature gradients and dew points through each building element. As the moisture-laden air in a building cools, it loses its ability to retain moisture. If it cools to below its dew point, liquid condensation will occur at that point. The Glazer method gives a good approximation of this condensation risk in most situations, and does so via a simple and easy to interpret process. There's also a lot of standardized material properties and conventions to guide designers in their use. The trade-off for the simplicity of the Glazer method is that the steady-state calculation assumes only a single direction of moisture flow and doesn't account for the effects of weather, moisture storage capacity of material, and a number of other phenomena. In most cases, though, this method is sufficient to indicate whether a more detailed consideration is required, and it can be used to quickly and simply compare a variety of solutions. Here at the Proctor Group, we provide a free U-value and condensation risk calculator on our website, which uses this method and a library of standard material types to assess constructions quickly and easily. Users can save multiple calculations arranged by project and share and collaborate with others in their team. They can also have the results checked by our team of experts before exporting fully building control compliant reports for their constructions. This type of construction, i.e. rainscreen, is well suited to the Glazer method due to there being little inherent moisture content during construction. But if a more detailed and in-depth analysis is required, BS 5250 specifies a more complex method to enable this. BS EN 15026 method is a fully dynamic assessment which incorporates most of the physics and material effects missing from the Glazer assessment. This method can predict accurate temperature and moisture storage profiles for any part of the construction, accounting for weather effects and the movement of moisture in any direction. This allows analysis of the performance of structure under any circumstances, even down to assessing differences in hygrothermal performance based on building orientation. The simulation can also be run across a wider range of time periods, potentially highlighting issues that may appear insignificant over a yearly cycle, but pose more of a risk longer term. Even factors such as the effect of solar gains on different colours of external cladding can be modelled. This type of assessment is a highly specialised undertaking, and there is very little in the way of standardised material properties or guidance available to follow. This means anyone using the calculation software such as Woofy must have sufficient experience in the use of the data available to them and ensure any assumption regarding material properties are appropriate to the application under consideration. A degree of skill and experience is also necessary to properly interpret the results of the calculation. So whilst BS EN 15026 is a powerful tool, it's far better suited to use on particularly unusual, high-risk or highly optimised cases. The results of these condensation risk assessments can be used to assess and confirm the effect of different combinations of insulation and membrane permeability. This allows the hygrothermal performance of the facade to be optimised to ensure a robust, durable and economic solution is achieved. In this way, it is possible to assess solutions such as removing the internal Avcl in favour of an external air barrier, which removes a potential source of complexity and reduces potential failure points in the design. When such highly optimised envelopes are designed, though, it's important to ensure they are built to the exact specification designed for, as superficially similar materials such as membranes and insulation panels may have different hygrothermal characteristics that render the assessment calculations invalid. If it does become necessary to change a specification, these changes should be reviewed fully and any calculations affected redone. Perhaps the most critical part of the facade design is the fire performance, particularly in high-rise projects. The fire performance, or reaction to fire, of building materials is assessed using the EN 13501-1 standard. This was first released in 2007 and updated in 2018, and assigns materials a reaction to fire classification based on their performance in a number of tests designed to assess the capacity of a material to spread fire. Different tests are required based on the classification a material is intended to achieve, and we have discussed the specifics of this in a lot more detail in a previous webinar. If that's of interest, you can view that on demand on our YouTube channel or contact us to book our REBA assessed fire and facades CPD with one of our team, either online or in person. EN 13501 or Euroclass classifications range from A1, which is given to materials that offer no contribution to fire, through to F, for materials with no tested performance. Classes D to A2 also have secondary classifications for the amount of smoke and burning droplets produced during the testing. So a typical classification will look like this. The main fire class from A1 through to F. The amount of smoke production from 1 to 3, with S1 indicating the least amount of smoke. The quantity of droplets from D0 meaning non-dripping to D2 meaning a lot of burning droplets. Following the tragedy at Grenfell Tower in 2017, fire considerations in construction were made much more prominent. Approved Document B was updated in December 2018, providing significant changes to what would be usable on external walls of relevant buildings. It has since been updated a few more times to provide clarity. Relevant buildings are defined as those with an inhabitable story which is 18 metres above ground level in England and Wales, or 11 metres in Scotland, and which contain one or more dwellings, an institution, or a room for residential purposes, excluding hostels, hotels, and boarding houses. In these relevant buildings, the amended Approved Document B specifies that all materials used in the construction of external walls should achieve at least Class A2S1D0, with a number of exceptions. These exceptions were provided for materials that are difficult or impossible to manufacture to meet Class A2 or better. Some of these are included by necessity. For example, intumescent materials react to fire by definition, and so cannot be non-reactive by the very nature of the material. This type of material includes intumescent paints which protect steelwork, some cavity barriers, particularly in rainscreen cladding systems, and our own fire shield breather membrane. Other systems are included in the list of exemptions as they are made of materials that may contribute to the spread of flame, but which there are no alternatives for. Typically, these materials are one that occupy only a small area of the building envelope, so whilst they may contribute to the development of the fire, this contribution is likely to be extremely limited, and is therefore outweighed by the benefits provided. Subsequently, Section 10.15 of the same document draws attention to the requirement for membranes as part of an external wall construction to meet at least Class BS3D0. As we discussed earlier, it's important with today's highly optimized building envelopes to ensure the as-built performance meets the as-designed criteria. This doesn't just apply to changes in design or specification, however. The installation process and good detailing is just as important. While some of the measures we've discussed can help reduce the need for complex detailing, it's still worth considering carefully every step to ensure there's no area in which what's drawn is excessively difficult to achieve on site. MCRMA members provide a wide range of products and services, and getting design teams and contractors engaged with manufacturers early in the process can help ensure everything runs smoothly. Here at the Proctor Group, we have a team of technical experts based around the country on a range of REBA assessed CPD materials to ensure specifiers are able to use our products to the best effect. We also provide a range of toolbox talks to installers and contractors to ensure they are aware of the best practice installation advice. While systems like our WrapTight and WrapTight UV membranes go a long way to make the installation as straightforward as possible, there are still a few important considerations around preparations of substrates and site handling to bear in mind. Some of these, for example, ensuring the substrate is free of sharp or uneven protrusions or lapping runs of membrane to shed water outwards, apply equally to self-adhered and mechanically fixed membranes alike. Others, such as ensuring substrates are free of dirt and dust, are less critical if the membrane is designed to be stapled into place. This variation in installation and detailing processes makes engagement with installers not only vital to ensure design performance is achieved, but it can also make working with unfamiliar materials a lot simpler. Ensuring all the various products and systems used in facades work effectively together is an important function of the MCRMA. Since 1990, the organisation has published a wide range of guidance documents, advice notes and CPD materials across all areas of metal cladding and roofing design. This guidance helps to interpret the broader building regulation requirements into application-specific advice, tailored to a more specialised audience. Today, we're very pleased to welcome MCRMA Director Carlton Jones to our Q&A session, which we'll move on to now. Thank you.
Good morning, everyone. I hope you all enjoyed today's presentation. My name is Carol Michalak, and I'm your host this morning for our live Q&A session. For anyone new with us this morning, we are here to answer any questions that you would like me to put to our panel of experts. So please drop anything that you would like to ask into the YouTube chat feed, or alternatively, you can send us a direct message to our Twitter page @Proctor Group, or you can email them over to webinar@proctorgroup.com. If there is something in particular that you would like to discuss with us in more detail, or if you'd like to order some product samples, or even arrange a follow-up meeting with one of the team, please just get in touch, leave some contact details, and someone will get back to you. Now, if you have registered for today, you will get a follow-up email from us, which in there will give you details on how to request your own CPD certificate. You will also in that email get a link where you can watch back the whole of today's presentation as well as this Q&A session. Please feel free to forward that on to anybody who you think might find this interesting. You can also watch back any of our previous webinars from the last 2.5 years. These can be accessed from our YouTube channel or from the online members area of our website. If you can, please subscribe to our YouTube channel. You'll get lots of updates on what we're involved in, as well as details on forthcoming webinar content. Please also give us a thumbs up and leave some feedback as well. All feedback is read and taken on board. It helps to shape the content for future webinars. Now, moving on to our next webinar, which is also now available for registration. This will take place in 2 weeks' time on Friday, the 9th of September at the usual time of 10 AM, where we will be covering pitched roofing design considerations. This presentation will give an overview of pitched roof design considerations and the regulations in UK and Ireland, along with discussing the type of construction membranes used as a pitched roof underlay and the effects their performance have on the design. It will also discuss the implications of hygrothermal focused roof design on the overall building energy performance. So another one not to miss. Mark this date in your diary and join us back here in 2 weeks' time. So let's move on now to our Q&A session and let me introduce you to our panel for today. First with me, we have a webinar regular, our Technical Director, Ian Fernington. Good morning, Ian.
Morning, everyone. Morning, everybody.
Good morning. Next up, we have James Brackenreid-Johnston, who is our Head of Facades. Good morning, James.
Good morning, Carol. Good morning, everyone.
Good morning. Next, we've got Paul Young, one of our technical advisors. Good morning, Paul.
Morning, Carol. Morning, everyone.
Good morning. And finally, our very special guest for today, I am delighted to introduce to you the Director at the MCRMA, Carlton Jones. Good morning, Carlton. Thank you so much for joining us.
Good morning, all.
Brilliant. Now, I'm really pleased to see that we've got some questions coming in on YouTube feed already. Please do keep them coming. And as always, just bear with me as I'm collating them in from various different sources. Okay, James, if I could start off with you. This question's come in on YouTube from Greg Robertson. Greg asks, if using the membrane on the outside, do you still need a VCL inside?
Thank you for the question. From our perspective, a hygrothermal analysis of the building envelope can determine that a vapour control layer may not be required in the build-up without causing any interstitial or surface condensation within the build-up. However, we do need to take into consideration factors such as the intended use, the build-up and construction type, the location, the orientation, and the moisture loadings of the property. We'll carry out analysis with and without a VCL and highlight how the build-up performs in both cases. So specific information on the products being specified in the envelope needs to be provided to ensure the correct result. Ultimately, from the construction type point of view, we take into consideration, obviously, the moisture loading within those inherent products in that build-up, So ultimately, if you've got an on-site concrete frame structure, the inherent moisture within that build-up will be more than if it was, say, precast concrete delivered to site, or if it was a CLT build. So it just shows that we need to glean as much information from the designer as humanly possible in order to make sure that the hygrothermal analysis that we carry out is specific to the project. Ultimately, in this country, there is a plethora of different designs of facade systems. So therefore, everything is bespoke and specific for each individual project.
Perfect, what a great start. Okay, Carlton, if I can come to you, here's one directly for you from Joseph Masterton. Does the MCRMA provide any training?
Yes, we do. Training, we've got a number of training modules and for application. We currently run a 3-day training course for roofing and cladding. This is an introductory course for competency. But in addition to that, we've got 20 CPDs, which are online CPDs, which members can read the document, answer the questions online, and then we'll get a competency certificate at the end of it. In addition to that, we're currently going through the process of setting up a wind load calculation process, which we'll have on the website to do BSEN 1991/1/4. So, and the National Annex. So yeah, plenty of training there if you need it.
Perfect. Thank you very much, Carlton. Okay, let's stick with the YouTube questions for just now. Ian, can I bring this next one to you from Olivia Reid, which Clarence has actually also commented on. Breather membranes confuse me. How can a membrane breathe?
It's a great question. Quite a lot of debate in the BS 5250 committee about breather membranes, where some of the committee are taking it too literal and exactly asking, how can a membrane breathe? The term is a colloquial term, which allows people to get an understanding that the membrane is vapor permeable, which is a better description of the product. But we've adopted this breather membrane technology so people understand exactly what the membrane does, and it's not a vapor control layer. So it's a bit colloquial. Breather membranes is a great term to use to get a good understanding that the term vapor permeable is better. So it can be a bit confusing sometimes. Added to that, you want to make sure that you're not considering an LR underlay, which is also a breather membrane, but the LR underlay is predominantly for pitched roofs. What we're talking about breather membranes here is for walls, where it's vapor permeable and it doesn't have the same water resistance requirements for a roof.
Perfect, thanks Ian. Okay, Paul, let's not leave you out. Let's come to you with another question on YouTube from Simon Wilson, who asks, what help can APG give? Oh, we could be here all day with this one.
Oh, no, yeah. Yeah, so I mean, internally, you know, we've got a team of experienced technical staff, and we're always available to kind of take your calls, answer emails on kind of any general question you might have on the products or the construction process. We can also do the calculations that were mentioned in the webinar just there. So the U-value calculations, the condensation risks, whether that's Woofy or the standard Glazer method. And we can also look at your drawings as well and kind of help you with the detailing to make sure you get the right air tightness. And externally, you know, we've got a lot of experienced individuals as well who can kind of come down to site, help give toolbox talks on how the products are installed. And we also provide a range of CPDs, which we're, you know, quite happy to arrange with you.
Excellent. Thank you very much, Paul. Okay, now I've had quite a few emails come in, so let me move on to some of these. James, if I could come to you for this first one from Peter, who asks, what are the advantages of self-adhered versus mechanically fastened? Oh, you're still on mute. Sorry, James.
There was obviously slides in the presentation highlighting from an on-site perspective how the material can enhance that. But if you take it back to the design stage, you can see the advantages from a designer's point of view. So if you're looking at inputting the external membrane into the facade system, then it will enable the target air tightness to be easily achieved. It will give the designer the satisfaction that knowing that obviously through the construction process, that air tightness line will be there. It will also give them the satisfaction that they know that that water holdout line will be there. Obviously, from our perspective, the wrap tight is watertight to W1. So it will stop any excessive moisture getting through that facade system into the actual building itself, which inherently has to dry out in the future. So in regards to the advantages for the installer, the material, obviously, as stated, fully bonds back to the substrate and itself, which means that there are no air pockets or secondary tapes to bond the material back to the substrate. And indeed, obviously, at the lapse of the material, it self-seals as well. Obviously, with a partially fixed, those bonds, those laps could fail due to, obviously, especially from a higher building's point of view, in regards to wind. The material is more robust and heavier, which negates tearing, but also eases the install because the way that the material hangs. These advantages increase the speed of install, which ultimately lowers cost and reduces down construction time.
Excellent. Thanks, James. Carlton, can I come back to you with this next email that's come in from Isaac? Is a rainscreen system subject to a harmonized European standard or a voluntary ETA?
Right, okay. It's an interesting one. As far as a rainscreen system is concerned, there is a need for a European harmonized standard to be able to CE mark your product against that standard. Now, in the case of a rainscreen, there isn't a harmonized European standard, but in 2012, a European technical assessment document was produced, which subsequently was changed in 2018 into a European assessment document. Now, that covers the rainscreen system, but the harmonized standard is a must-have and for being able to CE mark, but the European standard, an ETA and ETAG, are both voluntary from a customer's perspective. The rainscreen system has to carry a CE mark or a UKCA mark or Northern Ireland mark if it's got a harmonized standard, but unfortunately they're not available. So, but some of the individual products can be marked to their own harmonized standard or ETAG. Hopefully that explains it. It's quite a difficult one, to be honest, and certainly it's more complicated now going forward since Brexit. And going into January 2030 next year.
Yeah. Perfect. Thanks, Carlton. Can I stay with you with this next one? We've got another email that's come in from Abby, who's also got a query on the rainscreen. What other rainscreen related guidance documents are available from the MCRMA? Right,
okay. Obviously, the GD40 is the one that we've been discussing this morning on the membranes. As part of the portfolio of products or guidance documents for guidance from the MCRMA, GD08 is an introductory document to rainscreen. GD11 is fixings and fasteners. GD26 is aluminium fabrications, and that one is CPT approved. And finally, GD36 is covering cavity barriers and for ventilated rainscreen systems. So all of those are downloadable from the MCRMA website. But as I said, there's 2 out of those 5 are CPD approved. So you'll end up with a CPD certificate for that amount of work.
Perfect. Thank you so much, Carlton. Okay, Paul, can I come back to you with this next one? We've got a message come in on Twitter from Sean. Are vapor barriers not allowed?
Yeah, I can see why you might get that impression, because we do kind of score through it in the webinar. But it's kind of along the same lines as what Ian was saying about breather membranes. You know, it's more of a kind of common terminology. So when people talk about vapor barriers, what they're really talking about is the AVCL, the air and vapor control layer, and AVCL is the terminology that's referred to in the British standards. So a vapor barrier, barrier kind of implies that you just want that it's impervious to vapor, and it just stops all of it. But the reality is that, depending on the use of the building, you want a different level of resistance. And all it's there to do is obviously provide the air tightness and restrict how much vapor, or control how much vapor gets into your assembly, rather than stop it all completely.
Yeah, perfect. Thank you, Paul. James, can I come back to you? We've actually got two here, which I think your answer might cover. Clarence McAllister's got on the YouTube feed. Can someone give more information about what the limits for use of vapor permeable membranes in multi-storey buildings, particularly with reference to fire? But I've also got an email from Xander who says, for ADB and high-rise, is Class B adequate? I think they're quite similar, I do believe.
Yes, I mean, the Class B S3D0 is the stated performance requirement in the current building regulations. And indeed, we've had confirmation that will be included in the new regulations being implemented at the end of the year. The other understanding from the government in regards to the other performances and functionalities of the external membrane has been taken into consideration, along with the minimal risk to fire spread. So again, it's a backstop of Class B S3D0 is the minimum requirement for a external membrane in a high-rise system.
Perfect, thank you so much. Okay, another one here for you, Carlton, this time from Kevin on Twitter, who says, what is the MCRMA view on changing specification?
Oh gosh, kind of worms on that one. Certainly, in our view, specifications have been set by the design team, with their knowledge and understanding of what the building needs and the client needs. Changing specification at the post-design stage is usually done because of there's a need to, the product is not available. There's an opportunity to value engineer the product, or there may be the need for cost saving. In our view, it's very rarely done to upgrade or to provide an improvement in performance. So without the overall knowledge and understanding of what needs to be done for the building, changing specification can be quite a fraught area of activity. And of course, it's one which whoever changes the specification, they need to have the appropriate PI insurance to cover that change of specification. So yeah, it's a difficult one, to be honest, but it's not something which we would normally advocate. No, definitely not. Excellent, thanks, Carlton. Okay, Ian, if I could come back to you, we've got another email here from Phoebe who asks, BS 5250, what changed last year?
Okay, what changed last year? Great question. Quite a lot of committee meetings, quite a lot of debate. It's 179 pages if you're looking for a good read this weekend. Really nice, interesting stuff. But the fundamental thing was not least the title. The control of condensation was BS 5250. Now it's changed to the management of moisture in buildings. And the reason for that is to take more a holistic approach that there is other sources of moisture rather than just condensation. So we changed the title. We've put a lot more effort into it. We've realised that it's not just condensation, that sometimes in the UK it rains. So we have to take into consideration the rain, climate change as well. So there's quite a lot. I'm being flippant about a good read. It is really interesting. The basics goes from the basics to the final design. It's a really good document, but it's taken that all into consideration. And I think hats off to the MCRMA. They've done a great job of this GD40, which is giving you a real good summary specifically at rainscreen. Now, rainscreen was included in 5250 for the first time, more details. But GD40 is an excellent document if you're specifically looking at rainscreen.
Excellent, thank you, Ian. Okay, Paul, can I come back to you with this next one? It's come in actually from LinkedIn, from Michael. Why do a Woofy Calc?
Yeah, that's a good question. I mean, I'll start off by saying that you know, a Woofy calculation is not a necessity in the majority of assemblies. And you'll find in BS 5250, it does tell you where it is appropriate, and it tends to be mostly for solid wall assemblies, where you're putting internal insulation. A lot of that's down to, you know, the density and the porosity, also absorption of, you know, masonry and stone and all these kinds of materials. But it's also useful, you know, as Ian just said, you know, it sometimes rains here, so it's good to kind of take that into account, which the original condensation risk doesn't. You know, it's only looking at how the moisture moves through the assembly, you know, dependent on humidity and temperature. With Woofy, we can look at, you know, how much rain falls on, you know, each face of a building. You know, certain directions receive more rainfall. We can also look at how much of that water actually gets through the facade, and how much might be landing on the membrane behind it or the insulation. So it gives you a more kind of comprehensive look at the performance of the element as a whole. So if you're doing anything kind of non-standard, out the ordinary, that's not really defined in BS 5250 as a standard construction, it might be a good idea just to ask us about it and we can take a look.
Absolutely. And like Paul says, sometimes it rains here, sometimes in Scotland, just a little bit more than anywhere else. Right, thanks. Let's move on. Ian, can I give you this next one? We've got an email from Georgia. She asks, what about rain in open facades? How can this stop moisture problems?
Beautiful day like this in Scotland, we're talking about rain. Don't want to talk it too much over the weekend. So yeah, open facades can be a bit confusing. What we mean by open facades is more an architectural gaps, shadow gaps in the cladding. So sometimes you get some nice looking timber cladding with gaps in between it. A lot of the rainscreen by design has got gaps in it. So you have to be careful. We're not talking about the designed gaps in cladding systems where there's joints, but they're not big joints. They're designed there for ventilation and movement. But the open facades, where there is that gap, hit one, miss one type gaps, that does need consideration from exactly what we're saying. So the question asked was about rain. You need a membrane behind those types of cladding. And those types of cladding, what we invariably call facade membranes. So there's a black membrane specifically designed for UV resistance. We have one in our range. We have this type of membrane. This is the self-adhered version, which can be used behind the facade to direct the rain if it comes through the cladding and out of the building, and manages it's also breathable, so that during the construction you're allowing the vapor permeable to pass through. So yeah, you need a facade membrane if it's the open cladding, open facade, and that's also covered in the GD40 document and also from BS 5250 as well.
Perfect, thanks Ian. Can I actually stick with you for this next one? It's another email from Rohan talking about the rain screen again. He's asking what type of insulation is best for rain screen.
Well, Proctors we have some insulation systems, but we are to a certain extent insulation agnostic. So the team can give very good advice on what type of insulation to use, which ones not to use, but we don't actually supply it to the market in the mass market areas. But it is an important consideration. I'm obviously the technical director. Myself and the technical team have an invariable word that we use quite a lot, and it depends. So the insulation that we use can all depend on the type of construction. Do you want it vapor permeable? What type of the building? What height of the building is? The height of the building obviously post-Grenfell especially, you'll be concerned about the fire requirements if it's over 18 metres or 11 metres in Scotland. So there's lots of really good insulations, but all types of insulation will have some kind of Achilles heel. So the best thing is probably to speak to our technical team. We'll advise you what type of product. We won't necessarily supply that product, but we'll give you advice as to what type of product fits the application that you're dealing with.
Absolutely. Our technical team are a mine of information. They're so clever at what they do. So please, anything you're unsure of, just get in touch with them. If they don't know, they'll certainly know somebody who does know. Let's move on. Carlton, I've got another direct question for you here on email from Ewan, who says, your advertising campaign uses the strapline, the complete supply chain. What do you mean by that?
Right, okay. As the association, the MCRMA has got a membership structure, which is, again, throughout the supply chain. So system manufacturers, component manufacturers such as Proctors, installers, industry inspectors, and industry support mechanisms. So the group of companies within the MCRMA all know each other and have all worked with each other for many, many years, because MCRMA started in 1990 as an association, and we've been working through with members all the way through that period. It's one thing as far as the association is concerned, and certainly the members who are within the association, that the golden thread approach, which is something which Dame Judith has put forward, is a golden thread approach which the MCRMA and the members have been working on for the last 30 odd years. So it's a good practice, and it's one which we think will show that we have a complete supply chain throughout the association, and one that works very well and has done for the last 30 odd years.
Excellent. Thank you very much, Carlton. Okay, I actually only have a few more questions that have come in here. If anybody else would still like to ask anything, please drop it into the YouTube chat feed now, or ping us a very quick email. So let's move on. James, if I could come to you with this next one, an email from Kennedy, who asked, I see BS 5250 talks of ADT and ABIS. What is the difference?
Right. In essence, the differences between as design theoretical and as built in service should be minimal, which obviously goes back to Carlton's question from earlier in regards to specification. The idea is obviously for the builder, the contractor to stick to the specification that's been provided. So it's to emphasize the need for cohesion between the designer and the builder, to make sure the construction details and the specification are practical from an on-site perspective, and therefore be adhered to by utilizing appropriately skilled installers. So at the design stage, it's about making sure that the analysis of the whole proposed building envelope has been developed, taking into consideration both best case and worst case scenarios, especially regarding moisture, and implementing tangible resolutions that may arise at the construction stage. So the guidance in 5250 highlights the requirement for a holistic approach to all areas of the building envelope, and for the designer and builder to appreciate the performance of the walls, floors, pitch roofs and flat roofs, and very importantly, the junctions between these elements. To coin a phrase that I use a lot, the devil's in the detail. And that is where you're going to get your imperfections in the construction, is in the junctions between your slab, your sheathing, your column, your plenum details, your window reveal, door reveal details. So it's just working, obviously, from a design perspective to make sure that the nice straight lines that we all like are taken into consideration, that on-site, especially when it comes to formwork, may not be quite as straight and straightforward as we imagine them to be. So making sure that penetrations are homogeneously sealed will go a long way to making sure the building doesn't suffer in service from water ingress or indeed unplanned air movement.
Excellent. Thank you so much, James. Paul, can I come to you with this one? It's an email from Jacob, who says, how can I enhance the emissivity in the wall build-up? Yeah,
that's a really good question, actually. So, I mean, obviously, having a low emissivity will help the overall thermal performance of the wall. So generally what you'd be looking at would be to add reflective faces into the assembly. So, you know, we know a lot of insulation boards have a foil face, or you can also get, you know, membranes that go into the construction that are specifically designed to have the lowest possible kind of emissivity. So you also need to have an air void for the, you know, emissive performance to work. So what we would normally recommend would be in the case of a facade system, you'll typically have a service void internally. By putting a reflective membrane on the framework facing into that cavity, like I said, it'll boost your thermal performance, and what that can sometimes do is give you the opportunity to reduce the thickness of the insulation for some cost-saving measures. Or, you know, if you're looking to kind of upgrade, maybe go over and above what the current existing thermal performance is, then that's quite an easy way to do it without adding to the overall depth of the assembly.
Perfect. Thank you so much, Paul. Okay, I think this might be my last question, unless there's any latecomers come in during this one. Carlton, another direct question that's come in to you, from Tim on Twitter. I note that some organisations charge for their guidance document. What is the MCRMA's policy?
Right, okay. Our policy has always been that we're a technical-based organisation and an association, and the members are technically based as well. So the information that we've always provided is freely available to be downloaded from either from the MCRMA website or coming through to the technical line, which may we require us to redirect it to the member companies. We don't agree with hiding technical information and guidance documents behind a member's firewall or charging for that technical information. We feel that it's something that needs to be out there and needs to be out there for the guidance of the specifiers. Going on from that, and in my view, I believe that national standards and international standards ought to be freely available as well. It's something which members of the construction sector provide an awful lot of freely available time and effort into actually drafting these documents, and then the publishers get the fees for selling the document. So yeah, we strongly believe that information should be freely available, and from the MCRMA website, it's freely available.
Excellent, thank you so much, Carlton. Okay, we've got a latecomer just come in there. Ian, if I could put this last one to you from James Carrick, he says, when using vapor barrier internally and breather membrane externally at openings, which one should lap over the other?
Using the word depends, but I think generally you want to be, the breather membrane should be overlapping the vapor control layer. I noticed vapor barriers used there, so I don't want to upset Paul by mentioning vapor barriers. But generally, because the breather membrane is directing the water away, the rain that comes in, it would seem sensible to have it that way, rather than the other way where it could direct water inside the building. Obviously, the vapor control layer is used on the inside. So generally, you would have the breather membrane overlapping the vapor control layer, depending on the detail.
Excellent, thank you so much. Okay, I think that's probably covered everything. If there's anything at all that you would still like to ask, or if you would like to see some product samples, if you benefit from a one-to-one discussion with any of the team, or indeed book any of our new REBA accredited CPDs or the Toolbox Talk, please just get in touch and someone will get back to you straight away. And please subscribe to our YouTube channel, give us a thumbs up, and do leave some feedback. Register now for our next webinar, which will take place 2 weeks today, Friday the 9th of September at 10 AM, where we will be covering pitched roofing design considerations. Wow, September already, isn't it coming in quick? So from all of us here in front of the screen and behind the scenes, we'd just like to thank you, as always, for taking the time out of your busy schedule for being with us today. And from us also, huge special thanks to Carlton for joining us on the panel this morning. It's been an absolute pleasure. So goodbye from all of us. Enjoy the rest of your Friday. Have a wonderful bank holiday weekend and take care. Goodbye.
Bye.